NASA's Exploration Flight Test 1 is one of the most anticipated missions of 2014. The goal of the test flight is to check out key systems on board Orion, NASA's next manned spacecraft. The unmanned EFT-1 capsule is scheduled to launch aboard a United Launch Alliance Delta IV Heavy rocket. To get a better understanding of what this mission means to both ULA and NASA, SpaceFlight Insider sat down with ULA's Director of East Coast Launch Operations, Tony Taliancich.
Tony, first of all, thank you so much for taking the time to chat with us today.
Thank you for seeing me.
Now, let's talk a little bit about the Delta IV Heavy. I'm sure that's something that has got your interest. It has only flown DoD or test flights before this, correct?
That's correct. It's 7 previous flights, and in the past they've all been for either the test flight or the commercial or the government missions.
The public, can they expect to see anything different when this massive rocket takes off from those prior 7 missions, or would it be very similar? What can we expect to see?
There'll be a lot of similarities and some specific differences. From a similarity standpoint, it's the same Delta IV Heavy booster that we've launched 7 times previously, so it will look the same. There are 3 cores, each of which has its RS-68A engine on it, producing over 700,000 pounds of thrust for a total force at liftoff of over 2 million pounds. So a lot of thrust to support a very heavy payload. In this particular case, the Orion spacecraft will look different than the payloads that we launched before. The capsule on the top of the booster has a different look to it, and as a result, the front part of the booster is going to look a little bit different and provide some unique mission integration challenges as we go through it.
EFT-1 is the first flight of Orion. That's NASA's next generation crew-rated spacecraft. What do you personally think that says about your company, that it was your vehicle tapped to do this prestige-laden mission on behalf of NASA?
I think it says a lot about the confidence and the trust our customers put in us to be able to successfully launch their most important missions, the critical missions. United Launch Alliance has had a very good record of being able to successfully launch these critical missions, but also launch them on time when they need to be launched, so that they're not waiting on the booster to be able to support them.
In terms of the flow of the Delta IV Heavy and what it's going to be required to do, were there any major differences in processing, or, I mean, can you tell us a little bit about that? What was it like? Was it any different than the other Delta IV missions, the 7 missions you had prior to this?
So from a booster standpoint, there really are no differences. The heavy booster has been processed just like the 7 previous heavy boosters. All of the process, the flow to getting the vehicle ready to support the launch are the same, the test, checkout, verification. From the spacecraft standpoint, the Orion vehicle is different and required mission unique accommodations, some things that we had to modify inside the tower itself to be able to accommodate the larger diameter payload fairing, or the payload itself, and slightly higher payload than what would be typically accommodated in our tower. Most of that modification work's already behind us. When we get into actually processing the Orion spacecraft and attaching it to the top of the booster, there'll be a lot of mission unique support services, because this is a more complicated payload to support at pad Slick 37 than a typical mission. But all of that's been worked through years of planning ahead of time.
Orion, I would imagine, it's maybe heavier, maybe lighter. It's got a different kind of layout than a satellite or one of the normal spacecrafts carried out for DoD. So, well, the Delta IV Heavy have to conduct like a longer burn, shorter burns. Has there been a lot of changes to in terms of what the vehicle's going to have to do on that day?
The Delta IV Heavy vehicle was designed for a range of payloads. It's actually, it was originally designed to be able to accommodate anything from a geostationary satellite launched out of the Cape with a mass up to 14,500 pounds to a low Earth orbit mission going out of Vandenberg over 40,000 pounds. In the case of Orion, we're actually launching to a unique orbit, a very low Earth orbit, and then we're going to do this high apogee burn to get the speed coming back in of a spacecraft that weighs 47,000 pounds. So design of the booster supports it. The actual booster engine burn time and those things are unique to this specific mission. But they're all within family of what we've done before.
Now I'm going to ask you to prognosticate and see into the future a little bit. This is obviously a very important mission for NASA, and they've tapped the biggest beast in y'all's fleet to carry it out. NASA's budget's kind of flat since '08. do you see maybe a reignition in the public's interest towards deep space objectives, and could EFT-1 help to kind of reignite the public's interest in space?
I sure hope so. I think it's a really important mission, and I think the public will respond. Space exploration is something that the American people, I think, get excited about. American youth gets excited about, and so this mission has the opportunity to send a message to the country that we're making progress and that we're on our path towards deep space exploration for the future. The mission itself is a test, but it's the first step towards that new era of exploration that we're looking for in the future.
The real reason why we're called SpaceFlight Insider is we try to bring the public and their questions and their concerns about space to folks that can actually answer their question with, the most professional authority possible. So we bring this one to you. How did NASA approach ULA about EFT-1? What was that conversation like, and how did that make you feel about what your company was doing?
Well, ULA is very proud to be able to support this mission, to be selected to support it, but in reality, I think it's that initial conversation was about where can we get the most energy to be able to deliver this payload to the highest possible orbit and get that maximum test verification of the capsule itself. And Delta IV happens to be the most capable booster in the world today. The Delta IV Heavy has got that capability of getting this mission up to where it needed to be to get that re-entry speed necessary to support the test objectives. And ULA is happy to support that mission.
What you're currently working on right now, which is incredibly impressive, I have to say, how do you think that's going to impact what we're doing in terms of crewed spaceflight 5 or 10 years down the road?
I think this is the first step. It's a critical step to making sure that we're ready to take that first movement towards deep space exploration and support future human spaceflight, not just to low Earth orbit, but beyond. So we're positioning ourselves to continue to support it in the future, but you can't get there until you get the initial data that you need to support a safe and reliable system for the future.
Last question, and this is something we ask everyone. You know this question. You can probably answer it even, but I'm going to read it off anyway. If you had to tell the public what you think they should focus on about EFT-1, the things they should be looking for this mission, what are maybe some of the neat things that they can keep an eye out for? And they can say, oh, you know what, during when it goes to max Q, you're going to see this, or when the two CVCs eject on the side, they're going to see this. If you had to point ones out that you think that the public would enjoy or good information they could get, what would they be?
So first of all, this is going to be a beautiful launch. Delta IV Heavy is really spectacular. It comes off the pad very slowly, very majestically because of the thrust to weight ratio. A very heavy payload, a lot of fuel. The total stack weight of this vehicle at launch is going to be about 1.7 million pounds. And so you'll get a really long, majestic look at the vehicle leaving the pad. And then several minutes after launch, you'll actually see the booster cores, the strap-on boosters, come off of the core vehicle, and you'll be able to see those tumble back down as we continue up towards the booster separation and the upper stage ignition to do the final injection into orbit. So there'll be several stages of what's happening from the booster's delivery to orbit standpoint. The spacecraft itself is going to do 2 orbits around the Earth, and then we're going to do another burn to give it a high apogee trajectory, which will then bring it back down into the atmosphere at 20,000 miles per hour, which is the test objective. There'll be a lot of effort at that point to be able to actually recover the spacecraft, and so all of that coordination and timing is pre-planned so that we can make sure that when we launch the vehicle, we can also recover it on the other side.
Tony, yet again, thank you so much for taking the time to chat with us today, and thank all your great team at ULA for providing us this incredible venue. We wish you nothing but the best come December, and trust me, we'll be there covering it live.
Thanks, Jason. It was a pleasure.
Thanks, Tony. And for all you spaceflight groupies out there, make sure you keep it right here, right now, as we bring you all the best updates all the way up to the launch in December of Exploration Flight Test 1.
10, 9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running.